Hello students, welcome back. So we'll continue our discussion on reservoir and dam planning. Like we have been studying in last class, the sedimentation in reservoir, and then we discuss about the measures to reduce sedimentation. On this topic, we were discussing about the 5.5.4, that is creating a large reservoir. Now this point is a little bit contradicting with whatever we have studied till now, because we have said that when the capacity inflow ratio increases, the sedimentation increases, and now we are saying create a large reservoir, which we are saying, which is it's capacity. You're talking about the capacity, you're increasing the capacity. So when you create a larger capacity, the sedimentation will increase. That is the understanding. But there is, if we look the graph, the sedimentation versus inflow capacity ratio graph critically, then we realize that you can see here, you realize that this curve is not linear. With increase in capacity ratio, sedimentation does not increase linearly. Up to certain limit, yes, it increases, but after that it kind of remain constant, right? Yes or no? So till this region it increases, true, but after this it remains kind of constant. So if you construct a dam that or a reservoir that belongs into this domain, then of course there's going to be a sedimentation, right? But if you construct a reservoir with a capacity inflow ratio more than this one, then the sedimentation remains constant, right? Yes or no? So why don't we go by a very large reservoir? So that is the point. Okay, so if you are construct the reservoir in this domain, that is what it means. So large reservoir, of course there will be tremendous of sedimentation, but by going by this graph, the sedimentation remains constant. Even if you create very large dam, okay, the sedimentation would be same as of this one. So go for a very large dam. That is the meaning when we say this term, create a large reservoir. Although it is contradicting with what it is, what the actual thing is happening, but the sedimentation happening in the reservoir. But if we critically analyze the curve, then we realize that creating a massive reservoir, there is an added advantage, because the sedimentation is remaining constant, right? So that is one. Next one is, we are discussing about the methods to reduce the sedimentation. So next one we have on the list is control of sediment inflow. So how you're going to control the sediment inflow? So one way is constructing check dams. Check dams are constructed a little bit upstream of a main dam. Okay, so all the sedimentation occurs in the check dam, and later on you can remove it. And there's another one, vegetation screens. So basically what we were trying to say is cover the entire catchment with vegetation. If there is a deforestation, plant the trees, so that the root is going to hold the soil particle, and there will be less erosions, and the total sediment into the river reduces. The next one is control deposition. So like we say, to control deposition, the best way is by providing a sluice gate. So that is the most effective way. Okay, and there are some other ways so that there is less sedimentation, but the most effective one is the providing the sluice gate. There is also another method, that is physical removal of sediments. Okay, physically removal of sediments, which means now for a time being you completely let go the water, you make the reservoir empty, and then you remove all the sediments. But that is going to be pretty expensive. It's going to be very expensive. So usually this is not the choice. Okay, instead, like I said, a sluice gate would be a better option. And the last one is the soil conservation. Now soil conservation, yes, we talk about the catchment scale. We are not talking about the at the dam sites. We are talking about the catchment scale. So at catchment scales, then we talk about the, like I said, afforestation, control of deforestation, regrassing, and control of grazing, checking any gully sedimentation for a reservoir, for some checking foundation for small cracks and dam. Where is it? And effective controlling the sedimentation of a reservoir. So soil conservation are effective measures for controlling sedimentation in a reservoir to some extent, but are expensive. Because it's expensive because you are applying the technique in the entire catchment. Catchment can be very large, right? But these are very efficient long-term measures. Okay, and the next topic we have is losses from the reservoir. Now you have constructed a dam, there's a large reservoir, and you realize that the amount of water is drastically decreasing over the time. It could be because of evaporation. There, when you hold water in a large pond, then of course there is going to be a huge evaporation. So there are methods to reduce the evaporation. Next type of losses is the absorption losses. Absorption means once you construct the reservoir, then all the water rises up, right? Then it is in contact with the mountain sides, and this mountain sides may absorb water. Eventually this will go as a seepage into the groundwater, right? So this is one losses where in the preliminary phase only, if people see some kind of loose materials or a fractured rocks, they do the treatment. And like I said, this is the continuation, reservoir leakage and percolations. So within the where the dam is constructed, okay, within the site where dam is constructed, there could be some fractured rocks or swells that is highly permeable, that will lead to the huge seepage and losses. So during the construction phases only, if such stratas are found, then usually treatment is some kind of treatment is done for those fractured rocks. Okay, and for a large scale, grouting is used. Grouting is like you make a concrete paste, okay, then you spray over that region. If you wanted to see this done in the real world, you can visit the dam site, any dam site in country. You will see one most famous example is the Punajangchu phase 1 project. You can see along the dam site they are doing the grouting to control the landslide. They're doing it for landslide, but it can also serve the purpose to it can also serve as a barrier, so that there will be no seepage. Okay, so let's continue our discussion. Now we are going to discuss about the dam. So till now we were discussing about the reservoir. So reservoir is the pond formed upstream of a dam. So dam is a engineered concrete structure built across the river so that it can hold the enormous water pressure and make the to facilitate a reservoir. Okay, so dam is an engineered structure. So as you can see in this image, the dam comprises of a spillways, right? So a spillway, as I said, it is to let the water downstream. So during a huge flood, so this dam may be overtopped, so at that time you have to open this gate and let the water pass. And moreover, you cannot simply construct a dam and not let even a single drop of water downstream. The aquatic life downstream will die, right? So you have to let at least some minimum flow, which we call it as environmental flow, so from the dam. Okay, sometimes an additional spillway is provided at the periphery, which we call it as an auxiliary spillway. Sometimes the spillway is not constructed over the dam. Okay, here the spillway is not constructed, only the auxiliary spillway at the periphery is constructed. Okay, and in most of our dam in Bhutan, what we have is we have an intake structure and water is transmitted to powerhouse. Powerhouse is not constructed along with the dam. Okay, not along in the sense it is not constructed attached with the dam. So in some of the hydropowers, you will see hydropower the powerhouse is constructed attached with the dam, so there is a powerhouse. But in most of our case, we have the intake facility. Water is drawn from this intake facility and taken to the powerhouse to generate electricity. So okay, with this Let's continue. So preliminary investigation for a dam construction. So what kind of investigation is required for a dam construction? Basically, there are three types of investigation. First one is not exactly investigation, is a surveying, right? First one is surveying. Second one is geological investigation, very important. And third one is the hydrologic investigation, again very important. In engineering survey, what they do is usually they map out, they do the topographic survey of the entire stretch. For dam site, they prepare a contour plan of 1:250 or 1:500. Okay, that contour is prepared at the dam site. And for the reservoir, usually a high resolution, lower resolution contour is generated out of surveying. Okay, during the engineering survey, when you plan for a reservoir, so first thing you do is the engineering survey. This, in the olden days, people used to use the theodolite and dumpy level and the total station to do the surveying. Now people use very advanced technology like LiDAR, GNSS and GPS system to do the surveying of a large scale, and moreover it is accurate, and it is less time consuming. It's pretty much less expensive, okay, compared to this surveying, topographic surveying with the traditional equipments. Next one is the geological investigation. That is what you guys are expected to do. Okay, for geological investigation, the most important thing becomes to find out whether the foundation of the dam is suitable or not. Okay, for that there are various methods. They usually go for subsurface exploration. Subsurface exploration means they have to find what kind of strata, what kind of rock, what kind of, you know, the property of soil exists where you construct the dam. For this, as I said, they do subsurface exploration. And subsurface exploration, there is excavation of pits, open pits. They dig the pit and they take the sample out. Drifting or tunneling, they bore hole from the mountain to take out the samples. Okay, and vertical inspection shaft into the rocks, so they drill a hole into the rock to take out the samples. Core drilling is often to the sample to determine the configuration of the strata. So they do this to get the information. And they also check for water tightness of the reservoir. As the name suggests, water tightness means if there is a fractured or fissured rocks, you know, usually, and the cavities are there, then, and the porous mediums are there, these are not desirable. If it is such geological formations are identified, they will try to remove this and replace with the concrete, or they do some kind of treatment so that water is, you know, it is basically this is to conserve the water. If there is, if the strata in the periphery of a reservoir of a dam is the, you know, porous, then of course because of the seepage there will be huge losses, which is not it's required, which is not I mean, what to say now, which is, you know, not desired. So here the next point is the location of the quarry sites. Quarry site means where you extract the raw materials for construction. So if your quarry site is a little bit far, okay, then what happens is there's a cost of transportation, so the overall cost will increase. So if there is some quarries nearby, then this rocks or the material, construction material, will be utilized to construct the dam. And third one is the hydrological investigation. In hydrological investigation, they basically do the runoff pattern and yield estimation. Like I said, yield is how much product. Now when you translate that product term into a river, so it simply means how much water is available in the river. So you have to check, okay, how much water is available, whether that much of water is sufficient to fill up your dam in certain period of time. If that much water is not able to fill up, not the dam, the reservoir, then the site of construction of dam may have to be changed. So these kind of analysis they do. They basically do the discharge computations. They will see the possibility of high flood scenarios, low discharge. When there is a low discharge, whether the demand line is will be fulfilled or not with sudden storage. So this kind of analysis they do it. And next, as I explained already, is the maximum discharge. Maximum discharge here means the flooding scenarios. Okay, when a huge flood comes, then we have to have an adequate spillway, else there is always a chance of getting the dam being overfilled, and there is always a stability issue. If the dam is filled, or it's the level of water goes beyond the maximum level, then there's always a chance of some failure. So that is not desirable. So what they do is to calculate the maximum discharge that is possible in that catchment, and accordingly they will design the spillway. So even if there is a flood, we have a spillway to let off the flood discharge downstream. Okay, so this kind of analysis they do it. And the next topic we have is the site selection criteria for dam. So I have listed few, and these are not just the criteria, there could be many others. Okay, so let's go just scan through this because these are very self-explanatory. Suitable foundation must be available. Of course, if there is a foundation is weak, then of course it will have consequences later on. For economy, the length of dam should be small. Yes, if the dam is very long, then again it's going to be very expensive, right? So after you construct a dam, then you generate power. That power is in our case we sell that power. Now we also have to check in how many years the cost of construction can be recovered. Now you construct a dam that is so expensive that in next 100 years also you cannot recover the cost, then we are in loss, right? That would be a very stupid idea to do it. So we do this economic balance things. So if we cannot overcome the cost of construction, overcome here means if you cannot retrieve that much of money through selling the services, then it is a loss. So you may not go for that project, right? A suitable spillway, like I have explained during flooding scenarios. Basin should be reasonably watertight. If there is a large fractures, rock, porous medium, then water simply drains off in the downstream, so you cannot store that much of water. Yes. Materials required for construction should be easily available, true again, or else there will be implication in the cost. Value of land submerged by the proposed dam should be as low as possible. So it's like this. Usually in our country we construct dam in remote gorges into the forest, right? Because our river passes through the forest where there is no settlement. So even if we construct a huge dam, there is no damage to the citizens' property. There could be some, but in just take an example, in India, if you need to construct, it is a flat area, right? India is a flat area. If you need to construct a dam or a reservoir in a flat region, then a large area will get submerged. So you have to acquire the land. So the process takes very long, number one. Next is going to be expensive. Okay, a dam site should be easily accessible, and site for labor colonies, there should be a sufficient land for constructing labor colonies, because you will take massive labor force, and health services should be available. So if there is no health, you are doing a construction, right? So in construction there is a chances of accidents, so health services should be available nearby. So with this, these are some of the criteria. Okay, the list goes on. We have an exhaustive list, so these are just the highlights. Okay, now let's discuss about the classification of dams. Okay, we have basically 3-4 types of classification, maybe 4 types of classification. So let's go one by one. Okay, first one is the embankment type of dam. Embankment dam is in Bhutan we don't have this dam. It's earth fill dam. Okay, we're not using concrete like the image shows here. It's not the concrete dam. It is constructed out of earth, meaning it is constructed out of soil, and the innermost core is impervious. It is constructed such that it is impervious, and the rest of the material, these are all soil. Okay, and it said that 80% of the large dam in US are all embankment type dam. The next one is gravity dam. The gravity dam, the main the highlight of this gravity dam is its weight counterbalances the pressure. okay, pressure of the water, and it is a concrete dam. A concrete dam or masonry, and the span is narrow to keep the, to uh, keep the cost minimum. And this is that's it. Okay, this is the main highlights is the weight of the dam counterbalances the pressure force. Another one is the arch dam. The arch dam, now interesting part of arch and other dam is arch, as you see, is in arch shape, right? Is in arch shape. So let me draw here. So it's in, if this is a river, the dam is like this, and the main forces is transmitted into the periphery wall. So you can say in a sense the foundation of a dam is in its side. Okay, the all the forces is here, it goes here, it's transmitted here, and usually it is thin compared to other types of dam. The best example could be the Hoover Dam in United States. It is constructed in Great Canyon, right? So canyon is all rock, so it has a very good, the boundaries are very rigid, so that the arch dam is feasible there. Another type of dam is the buttress. Buttress means we give this kind of buttress here, this small these structures will give us this additional strength. Okay, so this will give the additional strength. So this is it. So I have given all the 4 types of dam here and all the levels, since the levels are in the the footnote, so you can make a quick reference. Okay, now selection of type of dam. So you have a site, you want to construct it, you have already identified a site. Now on that site, what are the factors that decide which dam you need to construct? So this is what we are going to answer here. So a narrow U-shaped valley, and the rocky wall suggest a concrete dam. So if there is a if there is a U shape, like in our case, okay, and there is a rocky walls, mean it is a rigid. So in that situation, the concrete dam is preferred. A rolling plain like India, okay, rolling plain, a low height dam is preferred, like an earth dam. Earth dam will never be constructed very high, unlike the concrete dam. Okay, narrow V-shaped is the choice of the dam, is the arch dam. Okay, and other factors are the geology and foundation. If there is a rock solid foundation like granite, it can hold massive dam, so you can construct a very huge massive dam there. Okay, if it is a gravel foundation, then you should go for a concrete gravity dam up to a height of 15 meters, and you should not go beyond 15 meters. Okay, 15 meters means 5-story building height. Okay, that is the height of a 15-meter, roughly 5-story building. Silt and fine. So silt and fines are not very good material for a foundation, so very low type of gravity dam is preferred, with height not more than 8 meters. If it is a clay foundation, then there has to be some kind of treatment. Okay, that foundation has to be treated first, then only it's advisable to construct the dam. Okay, now next factor that also determines which type of dam to be constructed is availability of material. You think of constructing the earth-filled dam, and there is no soil available of the required quality, then again transportation cost would be incurred, right? So that is going to be expensive. And other factors are spillway size and the earthquake zone. So our case is we are in very high earthquake prone area, right? So in that case, we also have to take into consideration of earthquake forces. And finally, we have the height of the dam. So what height is required? So based on that also we decide which dam. If it is more than 30, it is always constructed the concrete gravity dam. Okay, and there are other considerations as well. So with this, I would like to end this chapter here, and thank you. We will continue with next chapter. Thank you.